everybody. Welcome to Studio 64. My name's David, and I've been searching the interzones for some more science, space, and tech news to share with you. And I came across this little gem. Yes, this is a Popular Mechanics. A paradigm shift is about to make computing unstoppable. This should be interesting. They've got to say for themselves. Yes. Every computer needs random access memory or RAM for an operating system's temporary storage. There are many ways to achieve this need for memory speed. One of the leading methods is to I can't even speak today. I think my brain's operating on half a Biden. Magneto-resistive memory, which is both ultra-fast and non-volatile, meaning it retains data even if power supply is turned off. Now, a new discovery that analyzes how light interacts with magnets could make MRAM even better than ever before. Your computer wouldn't be very useful without RAM, which is short for random access memory. These chips function as the temporary memory storage for an operating system, and speed is of great importance as they are constantly needing to access bits of memory to keep everything running smoothly. Now, for more than 2 decades, the most advanced version of this technology, magneto-resistive RAM or MRAM, has been the go-to tech for the kind of intense computing necessary in industrial, military, and space applications. I can remember when Bill Gates came out and he said, because the limitation for DOS was 1 megabyte of RAM, and he couldn't, and of course 384 of that one megabyte, 384K, was taken up with the system applications, such as the operating system, the hardware, like your screen, your keyboard, your mouse, if you had one back in the day, serial ports, that sort of thing. And of course, 640K available for programming. And of course, he said famously, I can't see why anyone would need more than 640K of RAM. And that was the limitation on the hardware at the time, was 1 megabyte. Then, of course, don't say anything's impossible, because along came bubble memory, expanded memory, and the next thing you know, it's 2 meg, 4 meg, 8 meg, and going up now, of course, in gigabytes. So, eventually, one day once we've broken that limitation of hardware, we end up with quantum computing or biocomputing or something, that sort of thing, that bridge will be broken as well. I have the same theory with the light barrier. Everybody says the speed of light's impossible to break. It's a finite set. You'll never be able to do it. Well, we did it with memory. And don't tell that to the spirit of Chuck Yeager, who was told that he couldn't break the sound barrier. So I have very, very, very high hopes, not only for this memory, but also for, as a side note, one day breaking the light barrier or finding a way around it, shall we say, if not being able to break it. Now, a new breakthrough is discovered by scientists at the Hebrew University of Jerusalem has illustrated how a mechanism in a laser beam can control the magnetic state in solids, which the scientists described as a paradigm shift in our understanding of the behavior between light and magnetic materials. The results of this study were published earlier this year in the journal Physical Review Research. Now, this discovery has far-reaching implications, especially in the domain of data recording using light and nanomagnets. Amir Kapur, sorry Amir if I mispronounced your name there, head of the university's Spintronics Lab and study co-author, said in a press statement, it hints at the potential realization of ultra-fast and energy-efficient optically controlled MRAM and a seismic shift in information storage and processing across diverse sectors. RAM works by using incredibly tiny electromagnets that, once magnetized with voltage, can encode as on or off, ones and zeros in binary speak. Yeah, really very, very interesting, because you'll notice now with the advent of solid state drives, it's basically just really smart RAM. And of course, you can have a 4 gigabyte machine or an 8 gigabyte machine running Windows or Linux or whatever the case is, that's extremely fast. And you're thinking, would it be better to have 16 gig or 32 gig in there to make it, I've seen machines that are slower, probably because they have a mechanical drive. Now, don't get me wrong, if you've got a solid state drive, fantastic if you've got 16 gig or 32 gig. But it's basically you're saving to memory, this non-volatile memory. So it's really, really interesting. And as I said, obviously the more RAM you have, the better. But your long-term storage, if you can make that digital, you've got a really fast machine. Now, this breakthrough analyzes the often overlooked magnetic properties of light, which led the research team to discover that rapidly oscillating light waves can control magnets, a huge boon in the field of memory and data storage. Now, with their new mathematical equation, Kapua and his team were able to describe the strength of this interaction along with the amplitude of the magnetic field of light, its frequency, and the energy absorption of the magnetic material, according to the press release. Now, of course, the intersection of magnetism and light is old hat for the quantum realm, but the idea is rarely applied in the realm of spintronics, a portmanteau of spin and electronics that explores the relationship between an electron's spin and magnetism. This concept is what lies at the heart of MRAM, which uses an electronic spin to store information. Now, I'm not a scientist myself, but anybody out there is into this sort of hardware, computer science, or even a physicist, a quantum physicist, please feel free to comment because I'd love to hear from. It'd be great to get your input on this and see what you think of the possibility of MRAM. Now, we've arrived at a very elementary equation describing this interaction, Kapua told Live Science. It lets us completely reconsider optical magnetic recording and navigate our way to a dense, energy efficient, cost efficient optical magnetic storage device that doesn't even yet exist. But thinking of storage devices that don't yet exist as the era of quantum computing approaches, will need to come with quantum capable RAM as well. Live Science reports that such a technology could use a beam of light to fix a magnetic bit in a superposition of both ones and zeros, similar to how qubits work in quantum computers. For now, that future is still a way off. Today, MRAM is only beginning its ascendancy in the computing world, but this new discovery gives it a big boost as the memory chip of the future. Yeah, it does look exciting, doesn't it? I personally can't wait. I think that it's going to be absolutely incredible if we can get MRAM up and running in our machines sometime in the future. I think that it's going to be a great step forward. I mean, even getting solid state drives was a major leap forward in a lot of ways. Yeah. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
I'll be back.